Hi, this is Roel Yerro, an aspiring innovator, and I'm here to present about Graphene Supercapacitor as portable charger. Nowadays, almost everywhere we look, we can find people using mobile phones. In fact, about 90% of the population of over 16 years of age has one. Mobile phones have a multitude of uses to us, such as in communication, entertainment, and many more. As much as we want to use our mobile phones almost non-stop, we can't do so as there is a need for recharging. Our phones have lithium-ion batteries which has some disadvantages to it. One, it takes a couple of hours to be fully recharged. And two, it is prone to overcharging. Typical lithium-ion batteries with silicon as the anode experiences pulverization or cracking during overcharging. During lithiation, silicon anodes expand enormously up to 400% of its original size, then reduce to a varying size during dilithiation. This expansion produces stress and strain on the silicon particles, causing cracks and breakage. This yields low capacity stability and rapid capacity degradation over a number of cycles, or in other words, shortening battery life. A proposed alternative to the usage of batteries is the capacitor. Unlike batteries, capacitor charges faster but can't hold up the energy for long. Given this situation, an innovation of making a hybrid of both to get the best of the both worlds was done. This led to the birth of the supercapacitors. As observed in the Ragone plot, supercapacitor lies in between the battery and capacitor's power and energy densities. Supercapacitors have high power density, which means it can charge very quickly and discharges at a slower rate than an electrolytic capacitor. However, supercapacitors have a relatively low energy density, which means for a typical wounded aluminum foil supercapacitor to be able to power up an average smartphone, about half a kilo of aluminum foil should be wounded, and that would be very inconvenient to use. Further innovation led to the usage of graphene. Graphene is a tightly packed layer of carbon bonded together in a honeycomb-like lattice. It is lightweight and has a very high electric conductivity compared to aluminum foil. Stephen Voller was the man behind the utilization of graphene supercapacitor. His innovation, which is called Zap and Go, was an ultra-fast charging portable charger which he claims to get full charge in just about 5 minutes. They synthesized graphene using chemical vapor deposition or CVD. During the CVD process, gas species are fed into the reactor and pass through the hot zone where hydrocarbon precursors decompose to carbon radicals at the metal substrate surface and then form single layer and few layers of graphene. During the reaction, the metal substrate not only works as catalyst to lower the energy barrier of the reaction, but also determines the graphene deposition mechanism, which ultimately affects the quality of graphene. In general, polycrystalline nickel films are first annealed in argon-hydrogen atmosphere at 900 to 1000 degrees Celsius to increase grain size and then exposed to hydrogen-methane gas mixture. In this step, hydrocarbon decomposes and carbon atoms dissolve into the nickel film to form a solid solution. Finally, samples are cooled down in argon gas. Since nickel has a lattice similar to the densely packed hexagonal lattice of graphene, nickel's surface can serve as an excellent lattice-matched substrate for graphene growth. Here's an application for patent for the graphene supercapacitor charger, which claims that 1. Charger uses graphene supercapacitor. 2. Just like other power banks, it has an output converter to deliver direct current to an output port, thus safe for charging any devices. And 3. Due to the addition of graphene, which has a large conducting surface area, its charge density capacity improved. Finally, graphene supercapacitor can make breakthroughs when utilized in other fields. For example, we can have ultra-fast charging electric cars, which can also discharge quickly for sudden brakes, or we can directly incorporate the graphene supercapacitor to the mobile phone itself, thus giving us an ultra-fast charging phone which lasts long. This truly is an innovation that can surely be disruptive. So there you have it, graphene supercapacitor as portable charger, and once again, this is Roel Yerro, and thanks for dropping by.